right, before we get started, any questions over the homework assignments? So far we've had 7.1 and 7.3.1. What we're starting today is 7.3.2. 7.3.2 is going to be over our quotients. Quotient or dividing rational expressions. So quotients, we're dividing two rational expressions. And as we go through this, hopefully you'll be seeing that there is a strong connection between dividing two rational expressions and multiplying two rational expressions. Because when we divide two rational expressions, we're going to factor and then change it from division to multiplication and flip the second. Keep, change, flip. So we want to find the quotient of these two rational expressions. The first thing we can do is actually do our keep, change, flip. We can keep the first one the same, 7x over 2x minus 10. We change it from division to multiplication and flip our second rational expression. Now this is exactly like when we went through, or y'all went through, dividing fractions. We divide two fractions. We keep the first one the same. We change it from division to multiplication and then flip the second fraction. And then we multiply. So essentially, the only real difference between multiplying two rational expressions and dividing is that we keep, change, flip, and then we do the exact same thing. So essentially what we're doing from here on is what we did yesterday with multiplying two rational expressions. So after we do the keep, change, flip, we can factor and then multiply. So the 7x is as simplified as it gets. It's a single term. There's nothing we can do to it. Now the denominator for it, 2x minus 10, we can factor this. Is there a greatest common factor between 2x and 10? 2. So we can factor that 2 out. And if we factor a 2 out of 2x, we get x. Minus, if we factor a 2 out of 10, we get 5. So 2x minus 10 factors 2 times x minus 5. Do we want to factor the x squared minus 6x first, or the x squared minus 11x plus 30? X squared minus 6x, there's two terms. Is there a greatest common factor between these two? X. So if we factor an x out of x squared, we get x. If we factor an x out of 6x, we get 6. Now the numerator, x squared minus 11x plus 30, x squared, 11x, and 30 does not have a greatest common factor. So we'll have our two sets of parentheses with 3 spaces. Since the third term is positive, the signs are the same and match the sign of the middle term. So we'll have negative and negative. The factors of x squared are x and x. And the factors of 30, 1 and 30, 15, 3 and 10, and yes, 5 and 6. 5 and 6. Now, just like with multiplication, the denominator, the bottom of the fraction, does give us a hint because we do have x minus 5 and x minus 6, so there's a good chance those are the ones we need.
Tristan R., please come to the office. Tristan R., please come to the office.
And if we check this here, x times negative 6 would be negative 6x. Negative 5 times x is negative 5x. And negative 6x minus 5x is indeed negative 11x. That is the middle term we wanted. So these are completely factored, which means we can multiply them together. So on the top, the numerator, we'll have 7x times our x minus 5 times our x minus 6. On bottom, our monomials, those greatest common factors, it would be nice to have them multiply together, and especially out front. And our two monomials, those greatest common factors were 2 and x. So we can multiply them first, which would be what? 2x. And we can put them out front so that they don't get lost in the middle. X minus 5, x minus 6. Yes, because x minus 5 simplifies with x minus 5. X minus 6 simplifies with x minus 6. And actually our x and x simplify as well, leaving us with what? 7/2. So really everything simplified except for our two numbers. Yes, because when we divide two fractions, like 1/2 divided by 3/2, we keep the first one the same. We change it from division to multiplication and flip. Because when we divide two fractions, our division process is that we keep the first one the same. We change it from division to multiplication and flip the second. So for our second division one here, 11x over 3x minus 9 divided by x squared minus 5x over x squared minus 8x plus 15. Our first main step we can do is keep the first one the same, change it from division to multiplication, and then swap, flip the second rational expression. Keep the first one the same, change it from division to multiplication, and flip, swap the second. Now the first numerator is just going to be 11x. That's as simplified as it gets. Now just like the previous one, our two denominators, both of them do have a greatest common factor with each one. What would be the greatest common factor with 3x minus 9? 3. So if we factor the 3 out of the 3x, we get x. If we factor the 3 out of 9, we get 3. Greatest common factor with our x squared minus 5x? It would be x. Because if I take an x out of x squared, we're left with x minus 5. We take the x away from 5x, we're just left with 5. No greatest common factor between our x squared, 8x, and 15. So we'll go to our two sets of parentheses with 3 spaces. Since the third term is positive, the signs are the same and match the sign of the middle term. Negative and negative. Factors of x squared, x and x. Our factors of 15, 1 and 15, 3 and 5. I'm probably going to use 3 and 5. Because we're trying to equal 8, yes. Because negative, or x times negative 5 would be negative 5x. Negative 3 times x is negative 3x. And our negative 5x minus 3x is indeed negative 8x. Yes. Now really when we multiply, we're just putting everything together, yes? So really we can just connect those two lines. And our x minus 3 and x minus 3 will cancel. The x minus 5 and x minus 5 will is leaving us with 11 over 3. And 11 over 3 doesn't reduce. Questions on this here? Are we ready for the next one? Keep first one the same. Change it from division to multiplication and flip the second expression. Keep the first one the same, change it, flip. Keep, change, flip. Yes, so 5x minus 20 does have a greatest common factor of 5 when multiplied out, or factored out, not multiplied out. 5 times x minus 4, yes. Two. So if x squared minus 2x does have a greatest common factor of x, we can factor out, leaving us with x times x minus 2. It does not have a least common. Our signs would be minus and minus, x and x, 2 and 4. Because the only factors of 8 are 1 and 8 are 2 and 4. We're trying to get 6, and it'd be nice to have x minus 2 and x minus 4. So we multiply together, the x minus 2 and x minus 2 will cancel. X minus 4 and x minus 4 will cancel. Incidentally, the x and x will cancel, leaving us with. That's not always going to work out this way. Just everything simplifies out, but our examples do. Questions on this here? Keep change to multiplication and flip. So keep the 4a squared minus 1 over a squared minus 4. Change it from division to multiplication and flip the second one. Yes. Our a minus 2 and 2a minus 1 are simplified. Neither one of those has a greatest common factor, and since the degree is 1 with each one of those, nothing we can do with them. Those are simplified. So now we can look at, say, the a squared minus 4. It is going to be a difference of perfect squares. And for our a squared, it's a, and 4 is 2 and 2. And we'd have plus and minus. Now the question is 4a squared minus 1 a difference of perfect squares? Because what times itself would be 4a squared? 2a and 2a. What times itself is 1? 1 and 1. So 2a minus 1 times 2a plus 1 are our factors, and it is a difference of perfect squares. Questions on how we multiply or factored all this out? Well, now we can multiply all of this together. And let's see what's in common on top and bottom. Well, the 2a minus 1 and the 2a minus 1. The a minus 2 and the a minus 2, leaving us with what? That's it. Questions on this here? Keep y squared minus 9 over y squared. We change it from division to multiplication, and then we flip it, giving us y plus 2 over y to the 5th plus 3 y to the 4th. Y squared minus 9 is indeed a difference of perfect squares. Y plus 3 and y minus 3, or y minus 3 and y plus 3, the order in which we put those doesn't really matter. Y squared is as simplified as it gets, so it's not going to change. Y plus 2 is as simplified as it gets. There's no greatest common factor in the degree, so the variable or the exponent attached to the y is 1. Nothing we can do with it. However, the y to the 5th plus 3y to the 4th has a greatest common factor of y to the 4th, leaving us with y. So we factor y to the 4th out, we're removing 4 y's from each one, so y to the 5th becomes y to the 1st, and our 3y to the 4th, the y's factor out completely, leaving us with 3. Wrong direction. And we multiply these together. So the y plus 3 and y plus 3 will cancel. On top, we're left with y minus 3 times y plus 2. What are we left with on bottom? Which would be y to the 6th. Since they are like terms being multiplied, we add the exponents, giving us y to the 6th. So this is the first one where we had the same variable outside being multiplied.
Tristan R., come to the office. Tristan R., come to the office.
Questions on this here? Questions on anything we've done so far? We'll do one more like this here, and then we'll jump to the last type that we have. And I think we're starting to pick up on the fact that most of this with division and multiplication really revolves around us being able to factor. So here we keep the first one the same. Change it from division to multiplication and flip the second. And now we're going to factor. Again, whenever we're factoring any of the numerators and denominators, it's always good to look for greatest common factors first. A cubed plus 4a. Both these have a greatest common factor of a. So if I factor an a out of a cubed, we're left with a squared plus 4. And that's the only one in this one here that has a greatest common factor. Now we can go on and factor the a squared minus 16, because it is a difference of perfect squares. We'd have a and a for a squared, and 4 and 4 for 16, giving us a plus 4 and a minus 4. On our second numerator, a squared plus a minus 20. Since the third term is negative, our signs are opposite. Factors of a squared are a and a. Now our factors of 20 are 1 and 20, 2 and 10, 4 and 5. 4 and 5. Which one? 5 being positive, 4 being negative. If we check this, we'll see that we get negative 4a plus 5a, giving us the positive middle term of a that we wanted. Now that brings us to our last one, the a squared plus 8a plus 15. Since the third term's positive, the signs are the same and match the sign of the middle term, plus and plus. A and a, yes, I would agree, 3 and 5. Because it would give us 5a plus 3a, which is the 8a that we wanted. And again, we can multiply these together. And we see that a plus 5 and a plus 5, a minus 4 cancel. Does anything else cancel? No, it would be very tempting to want to simplify out that a plus 4, but the one on top is not a plus 4. It's a squared plus 4. Now, a squared plus 4 does not factor because we do not have a sum of perfect squares. A squared is a perfect square, 4 is a perfect square, but since we're adding and not subtracting, we can't factor. If it was a squared minus 4, yes, that would indeed factor. A squared plus 4 does not, unfortunately. So what that leaves us with on top is a times a squared plus 4 over a plus 4 times a plus 3. Questions on this here? We're going to skip that cubic one, not so much because it's hard or difficult. I think we get the hang of this. And most of this here, what we've done today and the last 2 days, has been less about, we're doing the multiplication, but it's mainly just factoring again. Now we did a problem like this yesterday, because we would say the second part of this here, what we're dividing it by, even though it doesn't have a denominator, the denominator is indeed 1. Now with multiplication, that didn't make a big difference. But with division, that 1 is going to come into play. Because our first step is to change it from division to multiplication and then flip the second rational expression. So now the 1 has gone from the denominator to the numerator. So we definitely have to list it this time. Now the nice thing from here is that, well, 1 is simplified as it gets. 4x squared is also as simplified as it gets. Now we need to figure out, do we want to factor the 6x squared plus x minus 15 or the 3x squared plus 5x first? Either one of them have a greatest common factor. Well, the 3x squared plus 5x has a greatest common factor of what? X. So I can take an x out of 3x squared and have 3x. And if I take an x out of 5x, we get 5. Now the 3x plus 5 is as simplified as it gets, because again, at this point, there's no other greatest common factors between 3 and 5, or our variables there. We pulled them all out. So the only thing that we have left that can factor is the 6x squared plus x minus 15. No greatest common factors. So we'll have two sets of parentheses with 3 spaces. Since the third term is negative, the signs are opposite. One's going to be positive, one is going to be negative. Factors of 6x squared. Well, we'll know we'll have x and x no matter what happens. 1 and 6, 2 and 3. Now it's trying to figure out which one we want. 2 and 3. 2 and 3 is a good guess, good place to start, yes? Are we going to put the 3 in the first set of parentheses or the second? First, and we do get a good hint. The bottom denominator has what? 3x plus 5. So if something's going to simplify, it'd help if we had 3x plus 5 as one of the factors for this here, yes? Because then we have a 3x plus 5 and a 3x plus 5, and they would simplify. Now, the only way this would work is if the factors of 15 contained a 5. Well, it does, yes? So that means we'll use 3 and 5. So again, figuring out or factoring the ones that we see first or seeing nicer has made 6x squared plus x minus 15. Yes. 2x minus 3, thank you. Yes. A lot nicer to factor. Because with the 3x plus 5, okay, picking the factors of 6 and 15 has now been reduced a whole lot so that we can actually see what we get. Now it is going to be good, or a good idea, just to make sure. 3x times negative 3 would be negative 9x. 5 times 2x is plus 10x, giving us a positive 1x, the middle term we wanted. So getting those others factored that are a little bit nicer helps us with ones that are a little bit harder where we have more factors we're trying to get through. Because we multiply this together, because we're multiplying all this. The 3x plus 5 and the 3x plus 5 will cancel. So what is 1 times 2x minus 3? Yes, and our 4x squared times x will become 4x cubed. And this is about as far as we can take it. Sometimes, I've seen it time and time again, that we want to simplify that.
May I have your attention, please? If there is any seniors who brought their write-ups for seniors tonight, they need to bring it to the office. Thank you.
And I've seen it a lot of times that we want to simplify the 2x and that 4x squared. But again, that 2x and that 3, the 2x minus 3 is one term. They're stuck together because of that minus. Now, there are ways for us to break that apart. And it goes back to our addition and subtraction of fractions. If we add or subtract two fractions, the denominators have to be the same. So really, to split this up and simplify, we'd have to split it up like this here, because when we subtract two fractions, we keep the denominator the same when we subtract the numerators. But has this made it simpler or more complicated? Now we have two fractions, and well, no. This is our final answer. We don't. This is not going to simplify any further from there without splitting it apart, breaking it down. We're not making it simpler. We're making it more complex, in my opinion. So that's as far as we have to go. Questions on this here? We're going to look at one more. Do we want to look at example 6, or this one, or the next one? All right. Keep the first one the same. Change it from division to multiplication. And we're going to flip the second. So now the numerator is 1. And the denominator becomes our 2x squared plus 2x. Five x squared, single term, it's as simplified as it gets. I mean, we can't also do anything with 1. That's as far as it goes. Now, we could factor 6x squared plus 4x minus 2 first. And I think factoring our 2x squared plus 2x might be a little bit nicer, because both of those have the greatest common factor of what? X and 2, because they both 2 and 2, common factor of 2. X squared and x have a common factor of x. And if we factor 2x out of 2x squared, we're left with x. When we factor 2x out of 2x, it factors out completely, leaving us with 1. Yes. Now we look at the numerator. 6x squared plus 4x minus 2. Is there a greatest common factor between 6x, 4x, and 2? Because they're all even numbers. And if we factor that out, 6x squared is going to become 3x squared. 4x is going to become 2x. And our negative 2 is going to become negative 1. Now there's two different routes we can go from here. We still need to factor the numerator. We still need to factor the 3x squared plus 2x minus 1, yes? Okay. Is there anything else left to factor? So we could leave it and rewrite it just like this is here, except we do the next spot our 2 sets of parentheses and go from there. We can do our 2 here. We rewrite all this here, and we go with our 2 sets of parentheses with 3 spaces and factor. Yes, the other option. There we go. Let's multiply. 2 times 1. 2. Now we are going to factor this to our 2 sets of parentheses. On bottom, the denominators are factored as far as they can go. We can't do anything else with them, yes? 5x squared times 2x. Cubed times, because we can essentially go on and start our multiplication and do the factoring at the same time. Nothing says we can't. 3x squared plus 2x minus 1. The signs are indeed going to be opposite. So we'll have x and x. X plus 1, 3x minus 1. Because we'd have x times negative 1, yes, negative x. 3 times x is plus 3x, giving us a positive 2x. Now there's a few things that simplify. X plus 1 and x plus 1. I want a highlighter. That's not a highlighter. Yes, the 2 over 10. So the 2 would reduce to 1. The 10 would reduce to 5. X cubed. Because we still, so the 2 over 10 does reduce to 1 over 5. Now, if it had been 2x over 10x cubed, it would reduce to 1 over 5x squared. but because there's not an x out in front here, it still stays x cubed. And the only other thing we have left on top is 3x minus 1. Because I think that you get, so without factoring out the 2's, I think you would get to 6x minus 2 over 10x cubed. Over 2x. So without factoring out the 2, I think you got to, that's a 2, over 5x cubed times 2x plus, and then those cancels and we get to the same spot. Yeah, both work. And that's it.